Hello, this is going to be a short demo where I walk you through the process of creating a simple container. And by a container, I mean a process that will be run using the OS's isolation virtualizations technology. All right, so first I will walk you through the steps that we will be doing. Then I'll actually run them and then show you the container and kind of point out a couple of things. So the first thing that we need is something that we'll call the root fs, which is essentially the set of files and binaries that we'll need to be um, the minimum Linux environment for our process. And what we'll do for that is we're going to do our first step, which is make a couple of directories, which will just essentially be some binary directories for putting different Linux commands. And to be our main source of these commands, we're going to use something called the busybox distribution, which essentially is a really super lightweight um, kind of distribution of Linux that contains a bunch of um, basic implementations of Linux commands. And it does it in one static binary. And it will actually use symlinks um, to emulate the calls. And now I'll kind of show you all those steps. All right. So I have my terminal here and I have a virtual environment. And I'm going to make a couple of paths that will be for my containers file system. So let me just make sure I have the right things here. So sbin and then rootfs user sbin. Okay. And so by using makedir with -p, it will actually make all these subdirectories for me automatically, which is convenient. Okay, so the next thing I'm going to do is I'm going to grab this binary file and I'm going to save it so that it's at root bin busybox. So that downloaded, then I need to make sure that it's actually executable so I can use it. And then this is just something I can use. So if I were to just run it, okay, so it's not going to work that easily because it works better when it's within the environment. So let's go ahead and do that. So the first thing that I'm going to do is I'm going to use change root, and I'm going to give it the path. Oh, okay, maybe I. Okay, so that actually did work. So you see root fs, and I'm just using the ls command that's provided within it, right? And here's an example of where I'm using its ping command, right? So it has a bunch of different binaries in it, but it's kind of inconvenient to call it this way. So one of the steps that I'm going to do here is I'm going to start with this change root um, program and give it a new root fs, and I'm going to tell it um, to run busybox install symlinks. And what it's going to do is, if you look at rootfs now, it will actually now make new symlinks um, to busybox, so that when you call it, it's actually going to be calling busybox itself. So this is kind of like an alias. All right, and let me actually test this out, where I will say change rootfs busybox ls. This is just testing out so this is me running again another command inside. This is actually running in the container. All right, but this is not really clear that I'm actually in the container when I do this. So what I'm going to do is I'm going to run this other command where I'm going to set a new prompt. change root fs, bin busybox, and just a shell. Okay, and so when I run shell, this shell is now running in the context of this container, right? And so when I do ls of my root, you could see it's now pointing to all these files I just made, right? And this is not pointing to the things that were in that virtual machine. And so what's different about this is the process that I'm running now is actually pretending like the root file system it has is these things here. And where this would be useful is if you, for example, needed to package up a Python program or Node.js environment, or any sort of running things, um, you would be able to have this root file system, along with the programs that you want to run, all prepared to ready to go, right? Without having to worry about installing dependencies, and et cetera. And the other benefit of this is it should be isolated, right? I should be able to not impact my host operating system. So what I can show you though is this is not exactly the case. So there's a couple different ways to see this. So for one, I could touch and create a new file. And if I were to exit and look at my root fs, you're going to see that that file is there. So what's that suggesting is that if I were to start a new container again, it's still going to be there. And if I were to delete this and look at it, so basically I could trash my root fs. So that's not ideal. There are also a couple other things like, so if I look at, okay, so so this is a good example here is I haven't fully integrated everything I need in the container. So for example, I haven't mounted the proc file system, which is necessary for getting things like the processes that are running in the kernel. And there are a couple other things like mounting dev that I would need to do to properly access other devices. So there are kind of two things wrong with this container right now. One is that I'm not fully isolated in terms of each instance of the container isn't really um, getting its own new instance. It's just basically looking at files on the disk right now, and it could change those. So in the next section, I'll show you how we can use the overlay file system to make a new environment for each container instance so that it would actually be truly independent. All right, so we'll stop here, and then we'll move on to the next section. But you should try doing this on your own.